Hi, and welcome to episode 56 of the ChessTDD series. It has been a little while, and for that, my apologies. Holidays and New Year and vacations and all that sort of thing, but back in the saddle and ready to take on the concept of check. So this actually, maybe I was hasty in apologizing. It was kind of a logical breaking point in functionality. So this is a brand new piece of functionality. I didn't find myself stumbling around a whole lot in knowing what to do next. Next up is going to be, in essence, evaluating check. To me, if I sit and think about it, is really the concept of threatening a square. So check means that the square containing a king is threatened, but we need to do more than think about check. We need to think about it in more abstract terms, specifically because when you're looking at castling putting you in check, or like where the king can move, you're not looking at whether the king is in check or not. You're looking at whether a speculative move would put the king in check. So really, you need to be able to reason about whether or not a given square is threatened by an enemy piece. The first, easy slice of this is really to forget about the exceptions. Pawn, I believe, is going. I don't know if there are any others, but forgetting about exceptions, pawn is an exception, and king can be an exception. For instance, a king can't threaten you if threatening puts the king in check. So that will get a little more complicated later. But for now, we can approach this by looking at whether looking at a square being threatened depending on whether or not a piece of the opposing color can move to that square. So that's kind of where we're going to be in this episode. And it is refreshing, and I find that this is always the case, it is refreshing to carve out a piece of functionality where you can actually kind of go at it with a simple unit test and not like adding to existing classes or carrying much cruft around from behind you. We're going to write a brand new class, and we're going to reason about new behavior, and we're going to proceed in this fashion. It is kind of reducing a mature code base to a little thing that you can do as if you were doing like a code kata or something, and that's what's here. Now that I've kind of gotten into this habit of having the board spin up classes that take this as a constructor parameter, I don't like that, and it's something in this project I will fix eventually, but for now it makes proceeding a lot easier. Sorry, that's my wedding ring banging against my desk. Let me take that off. So that, in essence, is a lesson to take away here. It is always going to make it smoother sailing, at least in the short term, if you can peel off a piece of functionality to just test at the unit level with only a class to worry about. Okay, so back to the design at hand. What I'm doing here is I'm creating this thing called Threat Evaluator, and I've decided that I'm going to pass in a board as a constructor parameter. At first I was thinking I might pass that into the method in question, but I was thinking, okay, well, if we just pass in a board, then we can go inquiring about a bunch of different squares in a row if we so choose. And that seems like a nice way to interact with this class. Now, I'm thinking that naturally I'm going to want to make this immutable. And the reason I say naturally is because classes with immutable state. So if I just pass in a board and I don't allow for the setting of a different board or nulling out of the board or anything else like that, if I just have the state of the class set at the time of construction, it becomes an awful lot easier to reason about the class and to interact with it. So my suggestion to you, whether it's for testability or just anything else, is always favor immutable state when possible. Don't go allowing the state of classes to change, unless I kind of like to design separate classes for that are domain classes. Those might change in state, but service types of classes, evaluators, etc., those I don't really like to allow for immutable state. It just mucks things up. It creates a lot more cases that you have to test and things that you have to reason about. Okay, so what I'm doing here in the first, this is kind of back to true TDD. as opposed to driving through acceptance tests or cobbling onto existing functionality, which means that for the first couple of tests, I can do some fairly obtuse things just to get going and to establish valid test cases as I build out this algorithm. So if I have an empty board, the first thing I'm going to say is that nothing is ever threatened. So and the easiest way I can express that is to just return false from is threatened and to let my next test case drive out when I need to make something different. So then in saying, okay, well, let's say that it returns true for if I put an opposing piece next to, say, I put a black piece next to a white rook, then that black piece should be threatened. So that told me, oh, right, I need to introduce the concept of whether this is a first player piece or not. Now, I have chosen to represent this elsewhere as a Boolean. Another option might be an enum or a little struct class or something. It seems fine as a Boolean, like is first player piece or not when creating the pieces. It's going to get a little bit weird here where I'm passing this Boolean parameter in. Now, one thing that I think is anathema, a Boolean parameter to a method is almost invariably, well, I would say it's a smell, and it's almost invariably a problem. It's a smell here, but not a problem, because actually the Boolean I'm passing in is data, but using Booleans as data is a little bit weird in and of itself. So this is something I'm calling out for later that we may need to revisit and reason about a little bit differently. But back to the present and getting tests to pass. I am putting this parameter in. It may be a little like speculative and unnecessary for this particular test in retrospect, but nevertheless, it's going to need to be there, so I don't particularly regret putting it in there. So what I'm saying is I am going to be, in each of these setups, I'm putting I'm going to put a black rook onto the board and then talk about it being a threat for the white piece. And that's pretty arbitrary, but I just want to get into the habit of making the pieces of the opposite color and not really thinking about it. So now I've got a properly failing test, because this setup here where I'm adding a rook at 1-2 and then evaluating whether or not that rook threatens 1-1 for an opposite colored piece, that should be returning true. And in order to get that pass, I'm going to have to declare this class level field board and start reasoning about what's on the board. Now, the easiest way to do that right now is let's return true basically if the board has any pieces on it, because that satisfies both our test cases. Nothing should be threatened on an empty board, and then we have a situation where there should be a threat and there's a piece on it, so let's just return whether the piece count is greater than 0 or not. That gets all of our test passing. And as I've touched upon from time to time, it is perfectly acceptable to do obtuse things to get your tests passing and to move on to getting more and more test cases written. It's acceptable to do obtuse things as long as you're marching toward a less and less obtuse implementation, as long as you're marching toward your eventual goal of how you want to implement things and get them done. So that is something to bear in mind. Return false is pretty obtuse. Returning whether there are pieces on the board or not is still pretty obtuse, but it's less obtuse than just returning false. And so with the next thing I'm going to want to do, I'm also going to want to get less and less obtuse. So I am in the interim now doing a bit of refactoring. I want to get rid of the duplication in these tests and maybe make them a little more readable. So first up, getting the target and the board situated. And I'm going to actually pull out an interim local variable name to make this more readable. So is the square threatened? I'm going to say, I'm going to set a Boolean equal to target is threatened. And that's how I'm going to make this call. And then I'm going to do the same thing in this second method, except the add piece is going to need to exist. Because that, what we're going to be doing in each of these tests is varying how we set up the board. So I want to get this to a more readable state where I'm striking the right balance between eliminating duplication and keeping the test nice and readable. And that is often a fine line to walk, as you'll kind of see as we go along here. I'm going to do something, I believe. I recorded the code for this yesterday, so I don't remember for sure. But I think I'm going to be doing something here where I actually abstract the act of the arrange act assert out to somewhere else. And that's sort of a dicey thing to do, but anyway, I'll cross that bridge in the narration here when we come to it. So next up, I'm trying to kind of go with an alternating false, true, false thing, but you don't really need to do that. I am just reasoning about ways that I can get more functionality that needs to be there into the production class. So right now I'm just returning true if there's any pieces on the board. That's obviously no good. So what do we really need to do? And I start to think about, okay, well, if I put a piece on the board that I know isn't threatened by the rook, then this is square threatened should be false. And I know that will advance the algorithm, so that's what I'm setting up here in the piece setup. So I'm going to place the rook at 1-1 and then grab the result of whether or not 2-2 is threatened, which is, as I describe in the test method, that is kitty corner to the rook. And this should not be a threatened square. And I know that's going to return, or that's going to fail. So now why is that failing? And I think, was there one more obtuse thing I can do here? I actually, at some point I said, gosh, I really just kind of need to implement the algorithm. I think that is probably a failing on my part. But as I was sitting here doing the coding, I started to think, okay, I can figure out where there's a piece on the board, I suppose. Or the first thing I thought of was this. I'll just go from 1-1 and get the piece there and figure out what squares it can move to. And then if the coordinate we're checking is one of those squares, I'll return true. Otherwise, I'll return false. Maybe in retrospect, I should have done that. I couldn't bring myself to do it, though, because it just seemed pretty close to just figuring out where on the board there are pieces. And if they're, the enemy pieces or whatever, returning true if it can move to the square in question. But I am not yet implementing the concept of enemy, so that is at least a miniature slice that I carved off. So this is, what I'm doing here is probably bigger than you're going to normally want to do with your jumps and functionality. I kind of did a couple of nice things to grow the algorithm a little bit, and then it's like I got impatient and just did everything. There will be times where maybe you just can't reduce it anymore, whether because it can't be reduced anymore or because you just can't wrap your head around it. The key thing, I think, is to just be in the habit of always trying to slice off as little as possible. You won't always succeed. Not every situation is uniform, and there are peculiarities and everything else. Now, as I look at this is a lot of code I'm writing, but it's not like conceptually that difficult. In essence, we're going to iterate through every square on the board and get moves from a piece that exists at that square. And then if in any of that giant mass of moves we find our coordinate to check, return true, otherwise return false. So I'm typing a lot of code, but it's not necessarily a ridiculous amount of conceptual functionality that I'm putting into place here. Just the iterating kind of creates the illusion thereof. And, there is some mitigation here. I mean, it's probably more code than I should have written. So I'm playing a little bit with, we're not reasoning about this in terms of zero indices. We're actually doing 1 through 8. I'm going to need to check to make sure the piece is not null. Otherwise, I'll be dereferencing null. And then this is where I'm saying, okay, let's get the moves here, and then we'll call it a day if we find it among these moves. So I'm going to get the moves from the row and column in question, provided there's actually a piece there. And then if among these moves we find the coordinate to check, we can just break out and do an early return of true. And then at the bottom, if we get through the whole thing and we haven't found any threats, then just return false. So as I said, a lot of code, but not conceptually all that difficult, but still more than I probably should have written. And here I was struggling with IntelliSense. I don't know if anybody listening to this has suggestions for how to solve these woes I'm having in this and my other series with IntelliSense just not catching up when I'm doing lambda expressions for. I've started noticing this only in Visual Studio 2015. Any suggestions I'm open to, because it's kind of annoying. So I'm expecting this to get everything to go green once I just say return false at the bottom. And let's see what happens. Yep, there it goes. So one more thing I'll say, I guess by way of justification, is if you're looking for a trailing indicator about whether or not you've bitten off too large of a piece of functionality, does what you're doing cause the test to do what you think it would do quickly? So if I had written all that code expecting green and then it hadn't worked and it got red, and a couple of them went green and a couple others went red or whatever, usually that is a trailing indicator that you've implemented too much functionality. If, on the other hand, what you saw here happen is what happened, which is, yeah, I wrote a lot of code, but everything worked exactly as I expected it, then it might be an indicator that you haven't actually bitten off too much, per se. So that's a good way to test yourself, to know if you're kind of biting off manageable pieces of functionality, because you can go in the other direction too, and you can really wind up writing or going too slowly. You're writing too many tests. You're being too conservative in how much you're advancing the production code. That is also a danger. So you're really always kind of trying to walk the fine line between moving along quickly and writing as few tests as you need to drive out the algorithm, and not biting off too much. All right, so anyway, back to the present. What I'm doing here is, now that I've got this algorithm in place, one thing I really don't like that you've probably noticed throughout the series is nested control flow statements. And so I'm looking at ways through a combination of link and method extraction to flatten out this method into something reasonable. And what you saw me doing over there on Stack Overflow is kind of looking, I'm looking for, I guess, kind of a clever way, I'll call it, to take the numbers 1 through 8 and spit out, like, I guess, a two-dimensional array, or, a list of board coordinates that iterate over every possible combination of those values. And at one point, my link foo was excellent. These days, since I don't do it nearly as much, it's kind of a combination of Stack Overflow, reaching into my memories, and IntelliSense, and I feel my way along, sort of. So I create that enumerable, and I figure I'll come back to that once I get this a little simpler. Now I'm trying to think of a way to extract a method from the stuff that's in the 2 for loops. That seems like a good way to divide this up. So what I'm saying is, does square attack. I'm getting the board coordinate for the row and column in question, and then I'm going to pass that in, and I'm going to call that the attacking square, or the attacker. And the one we're looking at, I'm going to call the victim. And then I can, using the guts of that nested for, I can tease out a method here where I'm going to say, we'll return true if we find it within those moves, otherwise we'll return false. And now what I can do is just call this method and kind of pass on the return there if it's true. So if the square attacks, then what I can do is return true, otherwise do nothing and just keep following through the looping. And everything's still green, so that's good. And now I can probably inline this and make it even a little more compact, and I like the way that's shaping up. Now I'm kind of looking at, like, okay, let me go back, first of all, and get my naming consistent. So I want to talk in terms of attacker and victim, I think, in this class is what I want to call these things everywhere. It's going to keep things consistent. Consistent naming is so important in reasoning about your code. Now, at this point, I think I went and wrote one more test. I don't remember if I know. It looks like I'm continuing to try to refactor. I do eventually, spoiler alert, get this flattened out into a link statement, but I don't remember if I do it before or after I decide to write a test that actually takes into consideration if the first player is attacking. Maybe I didn't even get around to that. I do not remember. I should really record the audio right after coding. So what I'm trying here is, I don't remember exactly how this works, and I ought to go back and look it up, but I do know that you can, in essence, tease like a list of numbers into actually two parameters. So I'm trying here to say, okay, and this doesn't get there. This is not the right thing. I added a parameter later. I think if I actually project each number with the actual original list of numbers, that gets me what I want. And probably I'd have to do select many because, well, anyway, what I'm trying to do here, I mean, you can see basically I want to get this list of numbers from 1 to board size. And what I want to do is project those out into a collection of all the board coordinates in question, and then say, are there any board coordinates in here where this, where the moves from that board coordinate attack the victim? And I'm bombing out on get piece. I think I'm doing like a bad range. So I was trying to mess with the ranges here to get this refactoring right. And I think I backed out of this for the time being. But the principle is still sound. I'm trying to, instead of, having these nested for loops to iterate over all the squares, I'm trying to do that in one declarative statement and say, get me every square on this board as a board coordinate. And then go through these board coordinates and see if there are any where the piece there attacks our victim square. So that's what I'm trying to accomplish. It's not going real well. And I was trying to figure out why. I know now in retrospect that I didn't get the link statement right, but I was kind of trying to look at the collection of board coordinates that were being generated by what I was doing. So, okay, I see that there's 1 and 0, and that's not great. I don't really know why that's happening. And so I was trying to figure out if it was getting wrong in the enumerable range, and then I went back to play with the statement. So I didn't need to make it select many, and then probably what's happening is that y is always 0, because there's, I'm taking a single integer, and then I'm defining an anonymous function with 2 integers, and it doesn't know what to make the second one, so it's probably making all those zeros. So it's 1 0 2 0, etc. I believe is what was wrong. But this told me, 1 0 2 2 1. Oh, that's interesting. I am not sure why the y would always be 1 less than the x. But that's something to figure out for another day, I suppose. So I think I need to make the x the only argument, and then, now, did I get this right here? Let's try select many, and trying to remember exactly. Yeah, this is right. And then this is going to project to the numbers and the, and then my XY combination. And then this is more muscle memory than anything. I really should go back and look up exactly what makes this link magic happen, but I kind of remember this from, bygone days of actually like writing link statements like this. So you've got to, anyway, now it's doing what I want, so I can get a little snazzier about these refactorings. And I guess I never did get around to use is first player attacking, but I've got the algorithm here that I like. So I'm going back and linkifying more stuff, and I'm using an early return here to further flatten things out, because what I can actually do now is just return false if the piece is null. Otherwise, I can return, this Boolean. And then there's even one more opportunity for flattening here, which is to make this an and. So return piece not null and this. So I'm really, and I love this declarative stuff because it really lets me do the initial obtuse implementation of getting using the old imperative style to loop through, and then figuring out how to represent it declaratively and make the methods a lot more compact. Now, I could probably use some better naming in here over the course of time, since this select many thing is confusing. But for now, it had gotten long in the episode. I was almost at a Pomodoro, so committing, pushing up to master, and then I'll take a look at the board real quick to make sure that we're in sync. But I think I'm just going to continue implementing this in the next episode. So, as always, thanks for watching, and I'll see you next time.